Good morning, students. Now let us see rate of convergence of the iterative methods. First, let us see the definition of rate of convergence. Rate of convergence. An iterative method is said to be of order P, small p, or has the rate of convergence p if this p is the largest positive real number for which there exists a finite constant c which is not equal to 0, such that modulus of epsilon n plus 1 is less than or equal to c into modulus of epsilon, let us take this one k, modulus of epsilon k plus 1 equal to modulus of epsilon k power p. What is the meaning of this here? Epsilon k plus 1 is the error at k plus 1th iteration, and what is epsilon k? Is the error at kth iteration, and here what is error? Generally error means what? Exact minus approximation, but for our convenient we are taking approximate root minus exact root is the error at a kth iteration. See, error may be positive or negative, but quantity is same. Now let me explain what is rate of convergence. An iterative method may be bisection method, regular policy, Newton-Raphson, Muller, Chebyshev, whatever the method, those are all iterative methods. It is said to has rate of convergence p or order p, or said to have order p. What is that thing here? There must be a constant c, real constant c, such that the error at the k plus 1th iteration must be always less than or equal to error at the kth iteration. What is the meaning of this statement? This one is, what is the meaning? Error at k plus 1th stage is always less than or equal to error at kth stage. This is the meaning. But here, and what is the meaning of that? K less than means what? That is error at k plus 1th stage. Has an upper bound. That means what? Error is bounded. The meaning is what? And when this type of expression exists, that is error at the k plus 1th stage is less than or equal to some constant into error at the k stage whole to the power of p, then this p is called rate of convergence. Expression meaning is, this is what? Error at the k plus 1th stage is always less than or equal to error at its previous stage, that is kth stage. This is rate of convergence of an iterative method. Means error is bounded. It has some finite upper bound. It has some finite upper bound. It has an finite upper bound. Okay, therefore error is bounded. And here the constant C is called asymptotic error constant. C is called asymptotic error constant. Asymptotic error constant. And it depends upon, and what it contains, this error, it depends on derivatives. C contains what? Derivatives of f of x at x equal to xi, at x equal to xi. And one more point just to explain the concept. Here what is error is taken as approximate minus exact. Here error is taken quantitatively, quantitatively means plus 2 error minus 2 error, means 2 is the error actually. What is error? Quantitatively 2 is the error. So we are ignoring the sign in the error, we are considering only quantity. Okay, this is one point. And let us see the first one, bisection method. What is the rate of convergence of bisection method? What is I already told you, bisection method. What is the condition of convergence? If the function, the condition is what? If the function f of x is continuous, that is enough. There is no need of any derivation. If the function f of x is continuous, then bisection method converges linearly. Then bisection method converges linearly. Linear means what? 1. Linearly, that is rate of convergence of bisection method is 1. Rate of convergence of bisection method is 1. Okay, why this is 1? Because in bisection method we have to bisect the interval, that's it. Okay, this is for example x0 and this is x1, this is the next root x2. If I consider this next root, the allocation of the root is here, positive and negative, then x3, like that. Means we are bisecting on a line segment, so it converges linearly only. This is bisection method. Coming to next method, what is that? Secant method. Secant method, rate of convergence C. First let me write what is a secant method. Assume that xi, exact root xi, is a simple root of, simple root means not repeated, simple root of f of x equal to 0. F of x equal to 0. Then what is the error? Error at kth iteration. Error at kth iteration is what? What is the error? Epsilon k equal to xk minus xi. That implies what? What is xk equal to? Xi plus epsilon k, right? Xi plus epsilon k. Remember this. This is one point. Xi plus epsilon k. Now, what is secant method formula? Let me write first. Secant method iterative formula is, secant method iterative formula is, what is the formula? Xk plus 1 equal to, isn't it right? Xk minus xk minus 1 by fk minus 1. This entire multiplied by fk. This entire multiplied by fk. So clearly I will write xk plus 1 equal to xk minus xk minus 1 by, what is this? F of xk. And what is this? F of xk minus 1, isn't it right? And this is what? F of xk. This is f of xk. Now let us substitute. This is xk equal to this one. So what is xk plus 1? Xk plus 1 is xi plus epsilon k plus 1, and xk minus 1 is what? Xi plus epsilon k minus 1. Is this clear? First one thing, what is to derive rate of convergence of secant method? Xi is assumed as non-repeated root, means simple root. And what is the error at kth stage? Epsilon k equal to xk minus xi, then xk equal to epsilon k plus xi, right? Xi plus epsilon k, then epsilon k plus 1, epsilon xk plus 1, and xk minus 1. I'm writing iterative formula of secant method, iterative formula of secant method, and elaborating f of x. Fk means f of xk, f of k minus 1 means f of xk minus 1. Let us substitute these three in this formula. Then what is xk plus 1? What is xk plus 1 here? So let me write xi plus epsilon k plus 1. What is this? Xk xi plus epsilon k minus, what is xk? Xk means xi plus epsilon k minus xk minus 1 means what? Xi plus epsilon k minus 1 by f of xk, that means xi plus epsilon k, right? And f of xk minus 1, xi plus epsilon k minus 1 into f of, what is this? Xk, xi plus epsilon k, isn't it? So what are the terms cancelled here? Xi gets cancelled, here also xi gets cancelled, right? So what is the remaining part? Epsilon k plus 1 equal to epsilon k minus, after cancelling the terms, the remaining terms are epsilon k minus epsilon k minus 1 by f of xi plus epsilon k is here denominator, and this is xi plus epsilon k minus 1 is here into f of xi plus epsilon k, f of xi plus epsilon k. Okay, now expanding what the terms here? Functions denominator f of xi plus epsilon k and f of xi plus epsilon k minus 1 in Taylor series, in Taylor series about the point xi, about the point xi, about the point xi. Okay, what is Taylor series? For your idea, I am writing here Taylor series. F of x plus h is equal to, first f of x plus h into this, h into f dash x plus h square by factorial to f double dash x, and so on. Here what is this? Is in place of x xi is here, in place of h epsilon k is here. Similarly x and h, this one. So what is this becomes then? This one, epsilon k plus 1 equal to epsilon k minus, this is epsilon k minus 1. Okay, and what is the numerator? Let me expand this. This function is what? F of xi plus epsilon k into f dash xi plus h value is what? Epsilon k, so h square by factorial 2 into f double dash xi, and so on, and so on, whole by, now denominator, first term f of xi, this first term f of xi plus epsilon k into f dash xi plus epsilon k square by factorial 2 into f double dash xi, and so on. This is the first function expansion, minus second function f of xi plus h into, what is h here? Epsilon k minus 1 f dash xi plus epsilon k minus 1 square h square by factorial to f double dash xi, and so on. This bracket closed, right? Now see which terms, and here one more point. Here what is f of xi value? F of xi is nothing but what? Xi is exact root, therefore f of xi equal to 0, so this value goes to 0, right? This value goes to 0, this value goes to 0. Now the remaining terms are epsilon k plus 1 is equal to epsilon k minus epsilon k minus epsilon k minus 1, isn't it? Next term, first term 0, epsilon k f dash xi plus epsilon k square by 2, right, f double dash xi, and so on. This is numerator. Coming to denominator, done. In this denominator, let me combine these two. F dash xi is common, f dash xi is common, so their quotient is epsilon k and epsilon k minus 1, okay, into f dash xi plus same logic, f double dash xi common, so what is the remaining part? 1 by 2 epsilon k square epsilon k minus 1 square f double dash xi and so on and so on. Okay, I think this is clear. What I am doing in the formula, I'm expanding that these two denominator, this one and this one and this one, numerator in Taylor series, and I'm substituting f of xi equal to 0. Why? Because xi is the exact root of f of x equal to 0. Now here see, in this part here, a square minus b square formula, so a minus b term will be common. What is a minus b? Epsilon k minus epsilon k minus 1 common, here also common, and here also it is there. So one more step, I will write one more step, epsilon k plus 1 minus equal to epsilon k minus epsilon k minus 1, and I will take f dash xi common. Therefore, this is epsilon k plus 1 by 2 epsilon k square f double dash xi by f dash xi, right, and so on. This is numerator, and in denominator I will take common a minus b term, epsilon k minus 1 is common, so entire bracket, what is this is f dash xi plus, here also you will get epsilon k plus epsilon k minus 1, a square minus b square, a minus b term is common, and this is f double dash xi, okay, and so on. So now these two terms gets cancelled. This is equal to epsilon k minus f dash xi bracket open epsilon k plus epsilon k square by 2 f double dash xi by f dash xi, and so on. And in denominator I will take this f dash xi common, so remaining part what? 1 plus 1 by 2 1 plus 1 by 2 of what? Epsilon k plus epsilon k minus 1 f double dash xi by f dash xi, and so on, right? Now these two terms gets cancelled, right? So what is the next one? Epsilon k minus, now this step, epsilon k plus epsilon k square by 2 f double dash xi by f dash xi, and so on. Take this entire bracket to numerator. Okay, what is that? 1 plus 1 by 2 of epsilon k plus epsilon k minus 1 f double dash xi by f dash xi, and so on, whole power what? Negative 1. And the most important point is you consider this entire as one bracket. Why? Because we have one formula. What is that? 1 plus x whole power minus 1 expansion, 1 minus x plus x square minus x cube, and so on. Now this entire term is taken as x, 1 plus x term. Let me expand that. What is this? Becomes epsilon k minus this one, epsilon k plus epsilon k square by 2 f double dash xi by f dash xi, and so on, right? And here this is I am writing only first term, first two terms up to this 1 minus x. So 1 minus 1 by 2 of epsilon k plus epsilon k minus 1 f double dash xi by f dash xi. That's it. Am I ignoring x square and the remaining terms? Okay, 1 plus x whole power minus 1 expansion. I am considering only up to first two terms only. Remaining terms negligible. Now take the product of this one. Take the product of this into this entire. What is this? Epsilon k into 1. Epsilon k into 1. Epsilon k. Okay, right? That gets cancelled. Better to understand this. Okay, let me write clearly in next slide. Okay, better next slide. See, epsilon k into 1 epsilon k, that will get cancelled. Okay, let me write one more step to understand, to explain. This is equal to epsilon k minus epsilon k plus epsilon k square by 2 f double dash xi by f dash xi and so on. And what is the expansion? This is 1 minus x. What is x? 1 by 2 epsilon k plus epsilon k minus 1 f double dash xi by f dash xi and x square and all those terms negligible. So this is equal to, what is this? Epsilon k minus, now entire product epsilon k into this one, epsilon k minus this minus into this minus plus, so plus epsilon k by 2 into epsilon k plus epsilon k minus 1 into f double dash xi by f dash xi, this into this term, total term. Next, coming to this, plus epsilon k square by 2 f double dash xi by f dash xi, and I'm neglecting the remaining terms. Okay, let me write square terms, epsilon square and the remaining terms I'm neglecting. If I want to write one more term, this minus and this minus becomes plus. Epsilon k square by 4, you will get epsilon k plus epsilon k minus 1. What you will get? F double dash xi by f dash xi, this whole square you will get, and so on. Right? All the product of one, how many terms? So this is epsilon k into 1 1, this is 2, and this is 3, this is 3, and this one 4. Okay, totally 4 terms, and this is epsilon k plus 1. So epsilon k plus 1, finally what I'm getting, this epsilon k gets cancelled, right? And what is this term? 1 by 2 epsilon k square plus 1 by 2 epsilon k square f double dash xi by f dash xi plus, right? Next one, 1 by 2 epsilon k minus 1 f double dash xi by f dash xi, right? Plus epsilon k square by 2. One thing, this is minus, isn't it, right? This is plus into minus into this everything. This already minus is there, no, sorry, this minus is already, so this is plus, this will be minus, and this into this plus, this into this minus. Now epsilon k gets cancelled, and multiplying by minus, this is plus, this minus into minus plus, these two terms are over, this minus into minus, this will minus, minus into plus minus, epsilon square by 2 f double dash xi by f dash xi, and minus into minus plus epsilon k square by 4 epsilon k plus epsilon k minus 1 f double dash xi by f dash xi, this one whole square, and so on. Okay, and so on, no bracket is there, no bracket, and so on. Therefore epsilon, now epsilon means error, very small error. Epsilon square means what? It's also very small. So epsilon square term, right? and epsilon square term. Neglect these terms. Neglect these terms. Then what you will get here? 1 by 2 f double dash xi by f dash xi multiplied by epsilon k into epsilon k minus 1 plus remaining all the terms can be taken as epsilon k square, right? Epsilon k square into what? Epsilon k minus 1, right? And epsilon k into epsilon k minus 1 whole square. Later on remaining terms, whatever that we neglect, those terms contains these epsilons. Epsilon k, epsilon square k minus 1. After simplification, there all the negligible terms are included here. Neglecting epsilon k square, epsilon k minus 1 square, and higher derivatives. Okay, so what is this is finally what I'm getting? Epsilon k plus 1, error at the k plus 1 stage is equal to, this is some constant c into epsilon k into epsilon k minus 1. What is c here? This part here, take this as equation 1. Here what is c? I told you asymptotic error constant depends on derivatives of function. So what is the derivatives? F double dash xi by f dash xi. This is asymptotic error constant. Okay, remember this equation. Epsilon error at the k plus 1 stage is equal to some c into epsilon k into epsilon k minus 1. But we need to determine rate of convergence, we need expression of the type. What is the type? It must be of what type? Epsilon k plus 1 less than or equal to c into epsilon k power p. Modulus is there. Okay, this should be only epsilon k, not epsilon k minus 1. Remember, k plus 1th stage here and kth stage only. But what we have? We have epsilon k plus 1 is equal to is there, so either less than or equal to c into what is the structure we have? Epsilon k into epsilon k minus 1. But we have, okay, to get the required expression, okay, we seek the relation of the form. Epsilon k plus 1 equal to some constant, another constant I am taking, epsilon k power p. This is 2. This is my equation 1. Okay, this is 2, where a and p are to be determined. Okay, now from this equation, therefore what is epsilon k becomes? A into k plus 1 k. Now here what? K means what? Epsilon, this is k minus 1 power p. That implies what is epsilon k minus 1 becomes? To keep this epsilon k minus 1 on right side, take every term onto the this side. So what is this one? Epsilon k power p equal to what? Epsilon k into a to the power of minus 1. Correct? I'm taking a this side. From this, what is this? Is epsilon k minus 1 is what? A to the power of, taking p onto right side, whole power 1 by p. So epsilon k power 1 by p. Okay, remember this. This is epsilon k minus 1, 3. Now substitute what are the values? Epsilon k plus 1 and epsilon k plus 1, 2 from equation 2, and epsilon k minus 1 from 3. Okay, in the relation 1 in equation 1. Okay, so what is 1 then? What is 1 here? It is 1 epsilon k plus 1. In equation 1, what we will get? Epsilon k plus 1 means what? A into epsilon k power p. right, equal to C as usual. There is no change in C. What is epsilon k as usual? Don't change epsilon k. Epsilon k as usual. Epsilon k minus 1 is what? A power minus 1 by p. Epsilon k power 1 by p. So what is this is finally taking this epsilon k. Okay, this is C into a to the power of, okay, take this a onto that side, so a to the power of minus 1 will be there on the right side. Okay, I will write one more step. This implies, let me write like this. This implies epsilon k power p equal to C into a power negative 1. Take this a onto right side, a to the power of minus 1 by p, isn't it, right? A to the power of minus 1 by p. And next one, what? Epsilon k power 1, and here epsilon k power 1 plus 1 by p, right? So what is this epsilon k power p now? This is equal to C into a to the power of minus 1 plus 1 by p, minus common, epsilon power 1 plus 1 by p. Okay, take this as 4, equation 4. Now comparing the powers of epsilon k on both sides. Don't cancel here. Okay, on both sides we get, what is epsilon k power here? P, left side p, and right side is what? 1 plus 1 by p. So this is what you will get, p square equal to p plus 1, that is p square minus p minus 1 equal to 0. So solving this equation, p equal to minus b plus or minus b square minus 4ac by 2a. So 1 plus or minus root 5 by 2. 1 plus or minus root 5 by 2. Now neglecting negative sign, because we will get negative value for p. P must be positive real number. Negative sign. Okay, what we have? P equal to 1 plus root 5 by 2, that is 1.618. Therefore the rate of convergence of secant method is 1.618. Is that clear? Okay, and why we are taking this p only? Because we are comparing, what is our error? Epsilon k plus 1 is equal to a into epsilon k power p. We consider here since, and what is p here? This p is 1.618. And what is a? And what is a here? A equal to c p by p plus 1 you will get. C p by, okay, comparing. How to get this one? Again, comparing on both sides. Comparing on both sides of 4. What you will get? 1 equal to c into a to the power of minus 1 plus 1 by p. Isn't it? Right? So from this, what is c equal to? A, sorry, I need a value. From this, what is a equal to? A equal to a power, take a this side, a power 1 plus 1 by p equal to c. So that implies a, what is this? P plus 1 by p equal to c. From this, what is a equal to? Exactly this. From this, a equal to this. Comparing constants on both sides. This is the constant, here constant is 1. Is that clear? Okay, a value asymptotic constant, a value is here, and the p value is 1.618.